13.1, multiplying and dividing expressions with common bases. This is just a really long title for something that you already know. We're going to talk about exponential rules. All right, that's what this is about. So first, what's an exponent? So if we have b to the n, b is the base, n is the exponent. I hope I didn't rock anybody's world with that information. All right. So what does it mean, for example, to be x cubed? What does it mean? X times x times x. That's it, right? That's what it means. All right, so we're going to start developing rules. And again, hopefully you've been exposed to these at some point before. What happens if I want x squared times x cubed? If I go back to the definition we just put up there, what is x squared by definition? X times x. And x cubed by definition? X times x times x. And so what we wind up with is x times x times x times x times x, which is the definition for x to the fifth. Do you see how that worked? So what we do is we then develop a rule here, so we don't have to go through that middle step. All right? And that rule suggests that if I have a base to a power and the same base to another power multiplied together, I get the same base raised to the sum. So multiply like bases, add exponents. You guys heard that before? There it is. And if that works for multiplication, what do you suppose is out there? Division, right? That's just unmultiplying. Right? Let's do x to the fifth divided by x squared. Right? So what does x to the fifth mean by definition? X times x times x times x times x. And x squared means x times x. What is anything divided by itself? 1, right? Anything goes into itself one time. So x divided by x is 1. X divided by x is 1. And what am I left with? X times x times x. And that is the definition for x to the third. You guys agree? So this suggests that if I'm taking a base to a power and dividing the same base to a power, I keep the base and simply subtract. All right? Does the order of subtraction matter? Yes. Right? Top minus bottom. 5 minus 2 is 3. So here are the rules in a nice orange box if that's what you wanted. If my handwriting just doesn't do it for you. B to the m times b to the n is equal to b to the m plus n. When you multiply like bases, you add exponents. B to the m divided by b to the n is b to the m minus n. When you divide like bases, you subtract exponents. Hopefully, again, like I said before, you've been exposed to this before. So what's 2 to the fifth times 2 cubed? 2 to the eighth. Now this is what gets people. The base doesn't change. All we changed is how many times you had the base. So it's still a 2. But if we have 5 of them and 3 of them, then we have 8 of them, but they're still 2's, right? 5 oranges plus 3 oranges is still going to be oranges, right? It didn't just become bananas. And if I had 5 to the 7th over 5 to the 4th, what would that be? 5 to the 3rd, that's fine. 5 cubed is fancier. Everybody okay with that? Moving on. 13.2, which is more properties of exponents. Right? That's not very helpful. It's just more. All right. So what would happen if I took x squared all cubed? So by definition, what does it mean to have something cubed? Something, 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 right? Yeah. In that case, that's x squared, x squared, x squared. You guys agree? That's what the cube means. Ah, but what does that mean? How many x's do we actually have? Yeah, we have 6 of them. That's x to the 6. Do you guys agree? Let me see some neck action. You guys are acting suspicious. Is this all right? Yeah, I know, right? I'm like, let me know you guys are okay. So when we have a base to a power raised to another power, what does it look like it's doing? You're multiplying the powers together. All right. So if we had a little orange box, there's the rule. B to the m raised to the nth power is equal to b raised to the m times n. When you have a base to a power multiplied by or raised to another power, you multiply the exponents together. Is that okay? Example. What if we had, oh, not the exact same one, 5 squared raised to the 4th power? What would we get? 5 to the 8th power. You guys agree? Now, contrast. What would happen if I had 5 squared times 5 to the 4th power? That's multiplying like bases where you add the exponents. Does that make sense? All right, do you see the difference? Those are the two that get confused the most often. If you have a base to a power raised to another power, you'll multiply those powers. If you have a base to a power times a base to a power, you just add them. All right? More rules. What would it mean to have xy all cubed? xy, xy, xy. You guys agree? By definition. Multiplication is commutative. If you multiply a bunch of stuff together, does it matter what order you multiply in? No. 3 times 4 is the same thing as 4 times 3, right? So I could rewrite this as x times x times x times y times y times y, and that's the same thing, isn't it? But by definition, that is x cubed and also y cubed multiplied together. So what does it look like we did here? Oh, I hate that word in this context. But I was waiting for somebody to say it so I could throw you in the pit and you could die on the spikes and we all learn. All right? Yeah. We can deal with an exponent piece by piece. All right? So if I have 2 factors in there, x and y, I do each of them cubed. So piece by piece. All right? And if that works for multiplication, well, what about division? X divided by y, all cubed, what does that mean? X over y times x over y times x over y. And how do you multiply fractions? Straight across, right? You just multiply straight across. So xxx over y, which by definition is x cubed over y cubed. More rules. Those are the rules stated in box form. If you have AB all raised to the nth power, it's a to the m, b to the m. If you have a divided by b all raised to the nth power, it's a to the m divided by b to the m. In other words, for multiplication and division, you can deal with an exponent piece by piece. All right? You can deal with an exponent piece by piece. Now, a huge, angry, in red warning. If I have something like a plus b, the whole thing squared, this is not, I repeat, not equal to a squared plus b squared. That is not true. You can't actually distribute exponents. That's not how it works. All right? Easiest way for me to prove that to you guys. What's 1 plus 2? What's 1 squared plus 2 squared? Not 9. All right? Okay, so it only works for multiplication and division. So don't say the word distributive. Only think about just doing it piece by piece for multiplication and division. All right? Adding and subtracting, not your friend in this context. So example. If I have 5y all squared, what's that going to be? Five squared y squared. And what is 5 squared? I was hoping for better confidence on that one. You guys are suspicious. All right, so next section, 13.3. More rules. All right. So now we're going to have two specific rules for zeroth power and negative powers. Again, you guys have seen this before somewhere, maybe deep in the brainstem, covered over in rust flakes, right, but it's there. What does it mean to be raised to a zeroth power? So let's explore. Let's say that I had x cubed over x cubed, right, for example. Now, on the one hand, what is anything divided by itself? So we know that that's equal to 1. On the other hand, in our previous section, we accepted that if I divide like bases, what can I do? Subtract. So this would be the same thing also as x to the 3 minus 3, right? But what is 3 minus 3? Aha. So what do we get? X to the zeroth power is?
It's right? Or nothing?
1. X to the zeroth power is 1. And what could x be? Anything, right? So this is telling us a rule. Anything to the 0 power is 1. Rule. Any base to the 0 power is 1. All right? 0 to the 0, that's a weird thing. You wouldn't even see it until calculus, so worry not. All right? So what is 3 to the 0 power? 1. What is pi to the 0 power? 1. What is 5x all raised to the 0 power? 1. What is negative 3 to the 0 power? You guys didn't fall for it. Why is it negative 1 and not 1? What is the base of that 0th power? What's the base?
The base is negative.
The base is just the 3, right? So 3 to the 0 is 1, but there's a negative in front. So what's negative times positive? Negative. How would I have rewritten this if I'd wanted it to come out 1? Use parentheses. If I have parentheses, negative 3 all raised to the 0, now who's the base of that 0 power? The negative 3, and that all becomes 1. Do you guys see the difference? All right. Similarly, if I have 5x to the 0th power and I don't have parentheses there, what does that mean? 5. Who's the base of that 0 power? The x. So x to the 0 becomes 1, but that's 5 times 1. You guys agree? Is everybody okay with that? Simple rule, but it's easy to make careless mistakes if you're going too fast. All right? Parentheses matter. Another rule. Let's say that I take x squared divided by x to the 5th. All right? Now, by definition, that would be x times x over x times x times x times x times x. You guys agree? Now, anything divided by itself, so x divided by x is 1. X divided by x is 1. And I have 3 of them left over, right? But where are they? In the bottom. So they have to stay there. Right? They can't just migrate. So that's an x cubed in the bottom, right? What's up top then? 1. You guys were talking me through it the whole time. X divided by x was 1. X divided by x was 1. So what's left in the top? 1. You guys agree? Now, that's how it works by definition. On the other hand, we have a rule that says when I divide like bases, I can subtract the exponents. So working this out the other way, this would be x raised to the 2 minus 5. But what is 2 minus 5? So this is x to the negative 3rd power. All right? So let's see what damage we've done here. X to the negative 3 means what? 1 over x to the 3rd. Is that okay? So what did a negative exponent do? It flipped it into the bottom of a fraction. Does that make sense? All right. So, b to the negative n power is 1 over b to the n. Right? Or we could also write that as just in all parentheses 1 over b raised to the nth power. Either one of those is fine. Either one of those is fine. Is that okay? Right. Example. What does it mean to be 3 to the negative 2 power? What does it mean? 1 over 3 squared. You guys agree? That's what we just learned. And what is 3 squared? 9, but that's in the bottom. So what is 3 to the negative 2? It's 1/9. So notice, we took care of the negative all on its own. That negative was its own rule. We handled it, and then we could expand from there. Does that make sense? All right. So what about negative 2 raised to the negative 4 power? Negative 2 in parentheses raised to the negative 4 power. Very good. 1 over negative 2 to the 4th power. Notice that a negative exponent is an entirely different concept from a negative coefficient. All right? They don't even act on the same playing field, so they don't affect each other. They're completely separate. Now, what do I do? So close. 4 negatives would make positive, and 2 times 2 times 2 times 2 is going to be 16. So this is 1/16. Is that okay? What if I had done negative 2 to the negative 4th, no parentheses? Then the negative is going to stay out front, and 2 to the negative 4th becomes 1 over 2 to the 4th. You guys agree? And what is 2 to the 4th, since we just did it? So this is negative 1/16. All right? You guys with me? Neck action. Is this okay? All right, exponential rules are one of those things. Like I said, we introduced them in the class before this one. We're doing it again. It's never going to go away. All right? You guys okay up here? And then, because I am a mean Mr. V, right, we can put all of these together. Mwahaha. All right. On page 795, they actually give you a nice summary of all of the rules that we have just reviewed briefly. All right, so you have a nice summary there. What do we mean when we say an expression has been simplified when we talk about its exponents then? We mean no parentheses, right? No grouping symbols are left. No powers on bases with other powers. No repeat bases. And no zero or negative exponents. So we would say that an expression is simplified if we have no parentheses left over, we have no powers on bases with other powers, right? We have no repeat bases. So if there's an x in one place, we can't just have an x running around somewhere else, right? There's too many x's running around your life. Right? No zeros or negative exponents either. Now, there's no set order to dealing with these. As long as you're using legit rules in a legit way, you'll get to a legit answer. However, if you just want to take this as a guideline for how to approach it, that's not bad. It gives you something consistent to kind of grip onto. This is how we can go through and simplify. We'll take care of any parentheses. We'll take care of any powers on bases to other powers. We'll take care of repeat bases, and then we'll take care of negative and zero bases or exponents as well. All right, so let's say that I give you something like negative 3x to the negative 6, y, all in parentheses, to the negative 1. And then negative 2x to the negative 3, y to the 4th, all to the 2. All right, so we want to simplify this. So we just need to go through and apply our rules. So if we take it in order, which again, you don't have to. It's as long as you're doing all the legitimate steps, you'll get to the right answer. But why don't we clear those parentheses first? How do I deal with parentheses raised to a power? Just do it piece by piece? Does that make sense? So everything in the first set of parentheses gets what? A negative 1 power. Everything in the second set of parentheses gets what? A power of 2. Does that make sense? All right. So that's what we're going to do. We're going to clear those parentheses. What happens when you have a base to a power raised to another power? Okay. So this means I have negative 3 to the negative 1. I have x to the positive 6. Y to the negative 1. Do you guys see what I did there? Everything in the first parentheses got a negative 1 power. And when you had a base to a power raised to another power, you multiplied that in. So what about the second set? That's negative 2 squared. X to the negative 6. Y to the 8th. Is everybody with me on that? It's just one rule. Do you see how we applied it? Right, if you take it one step at a time. You don't eat a peanut butter and jelly sandwich by just stuffing the whole thing in, right? One bite at a time. Chew, swallow, then bite again. Okay, so I know we have these parentheses on the numbers, right? We'll have to deal with that. But other than that, we're all cleared. Do I have repeat bases? I have no more bases to a power raised to another power, but do I have repeat bases? Yes. So we have to handle that. There's no other base of -3. It's on its own. There's no other base of -2. It's on its own. We do have the base of x twice. And isn't that all multiplication? So what happens when you multiply like bases? We're going to add the exponents. So I've got -3 to the -1. I've got -2 squared, because we couldn't do anything with those. And then I wind up with x to the 0. You guys agree?
Wait, how did you do that again?
So we had x to the 6 and x to the -6. When we multiply bases, what do we do with the exponents? We add them. What is 6 and -6 added together? What happens when you take 6 and -6? You get 0. And we get another shot at it because we also have y repeated. You guys agree?
So that's why we got rid of y, right?
Let's see what happens. So I'm multiplying those bases, right? So what do? Add the exponents. So what happens if I take -1 and 8 and add them together? We get 7. Did that help?
Yeah.
So I had 2 of them in there, so I could bake your noodle with the first one and then clean it up with the second. All right. Okay, so no more repeat bases, right? Last thing we need to do, if I have negative exponents or 0 exponents, we got to take care of those, right? So that -3 has a negative exponent. What does that mean? It goes to the bottom. And on the bottom, I have -3 to the first, right? -3 just to the first. Is everybody okay with that? Now, if you have a power of just 1, do you have to write it? No, it's understood. So we can just write -3. What about -2? Does that also move to the bottom? Yes or no? It doesn't. Why not? It's not a negative power. In fact, we can do a square. What is -2 squared? That's a 4. You guys agree with that? What's x to the 0th power? 1. I don't have to write times 1. And then finally, y to the 7th. Does it move or stay where it is? It stays where it is. Y to the 7th. And that's it.
Why didn't you put the x?
Because anything to the 0th power is 1.
Okay.
Anything to the 0 power is 1. So what's 4 times 1?
4.
Is still 4. So does that make sense? Whew. Let's do another one. Let's say that I give you x cubed y to the 5th over 2x to the 6th y to the -2 all raised to 2 times x third y to the 5th over 4, all raised to the -3rd. This is nothing to you guys. It's just scary to look at. If you just take it one step at a time, use those rules, you'll get to the right answer. So what should we clear first? Right? Parentheses, right? It's general guidelines. So how do I deal with an exponent outside parentheses? What does that mean? Everybody gets it, right? Everybody inside multiplication, division gets those outside powers. So everything in that first set of parentheses gets that square, right? So this means I have x to the 6th, y to the 10th, over 2 to the 2nd, x to the, I hear one person whispering on the winds, 12th, y to the -4. When you have a base to a power and you're raising it to another power, you just multiply those numbers together. Is everybody okay with that? You see how I did that on that first set of parentheses. Is that okay? Is that all right? Go for it.
What if there's a negative outside? Would that just flip?
Ah, let's look at the next piece. Such a timely question, Grasshopper.
I'm talking about if there was a negative, like in the denominator.
Okay,
And
there.
a negative on the outside. You
Sure.
know what I'm saying?
So we'll do it. I'll put a negative in there. I can be as negative as you want me to be. All right.
I'm talking about nothing. I don't know what I'm trying. I know what I'm trying to say.
Let's see how this works. So I put a negative in there just to satisfy. So what do? Everybody gets the -3. You guys agree? So we get x to the -9, y to the -15 over -4 raised to the -3. Were you talking about a negative power on the inside?
Yeah.
Well, what's a negative times a negative?
Positive.
There you go.
That's what I'm saying. So would that just leave the denominator alone?
No, let's say this was a -3. That would be a +9.
I was talking about in the denominator. Like, if that was -4 raised to the -3rd. You get what I'm saying?
Yeah, so then it would be a negative times a negative, which would be a positive power.
So wouldn't that go on top?
Let's deal with that last.
Oh.
All right, let's deal with that last. Right now I'm just trying to get those parentheses cleared. All right? In theory, you could go ahead and do that as well. If you're desperate to flip, you can start flipping early. And it's fine. As long as you're applying the rule, you're okay. But let's just take it one step. The answer is still going to be a fraction. Just you're not going to escape your fate. All right? All roads lead to Rome. And by Rome, I mean the 9th circle of hell. Okay. So we've taken care of those parentheses. How do you multiply two fractions together? Straight across. So just make it one big happy fraction bar. All right. Okay. Do we have repeat bases? Okay, we have a bunch of them, right? So there's nothing we're going to be able to do with 2 squared. That's just going to be its own base. We're not going to be able to do anything with -4 to the -3 yet. If we're just talking about repeating bases, there's no other -4 out there, right? What about x's? I have 3 of them, right? Now you guys can take this as slow as you want to, but if I'm multiplying those two, what am I doing up top? Adding. And if I'm dividing this one on the bottom, what am I doing? I'm subtracting. So we have a 6 plus a -9 minus a 12. You guys agree? What is that?
-3 minus 12. That's -15.
-15. So I have x to the -15. Oh my gosh. You guys okay with that? All right. Well, let's see if lightning strikes twice. I put a y in there so you can see that as well. All right. Y lets you see y. I've got y to the 10th, y to the -15th, and y to the -4th. If I'm multiplying like bases, those are going to be adding their exponents. And then the one that's dividing, I'm going to be subtracting its exponent. So this means I have 10 plus -15 minus -4. You guys agree? So what is 10 minus 15 plus 4? y to the negative 1. Right? One rule to rule them all. Right? I got a little overexcited with that fraction bar. I guess I'll dial it back. All right, so we dealt with those parentheses. We dealt with those repeat bases. All we have left to deal with is we have some negative exponents around, right? If we had zeros, we'd have to deal with those as well, but we don't. So what does the negative exponent mean? Yeah, stuff's going to start migrating. So let's start with who isn't moving. Yeah, 2 squared is going to stay where it is. That's 4. Meanwhile, we get negative 4 cubed up top. You guys agree? Meanwhile, we get x to the 15th on bottom. And we get y to the 1st on the bottom. And I don't have to write a power of 1, so I can take that back. So negative exponent means you have to flip it, right? So if it's in the top, it flips to the bottom. If it's in the bottom, where's it going to flip to? It's going to flip back to the top. It's a great question. Let's see some neck action. Do you guys see how those negatives were dealt with? All right. Negativity is actually easy to get rid of in life. You guys need some practice with that. What is negative 4 cubed? Spoiler alert, it's negative 64. You can always just put 4 times 4 times 4 in your little calculators and pull that warm blankie over you. It'll tell you the right answer. 3 negatives will make negative still. Does that make sense? Now, does this reduce?
4 goes into 64.
How many times does 4 go into 64? 12 is right. Or, sorry, 16.
Oh, 16?
Yep. You said it with such confidence.
I tried. I knew it was up there somewhere.
Yep. So we have negative 16 over x to the 15th y.
So when I was doing this in Alex too, it wasn't having me simplify it that much. Is that how you would like it further?
I'm giving you some really tough ones here. I mean, I kind of threw the kitchen sink at you. Some things don't simplify.
Do you want it for the test like
Yes.
just like that?
Simplify all the way. All right? Now, for some of the rules, like if you run into something where it's like, what is 2 to the 5th all cubed? That's going to be 2 to the 15th, right? For something like 2 to the 15th, you're probably not going to write out what that number actually is because it's going to be a really big number. So you would just write 2 to the 15th. Does that help? Mm-hmm. Okay. That's in the context of just using the rules. All right, so you're going to spend some time reacquainting yourselves with those wonderful, lovely, powerful rules. Meanwhile, in 13.5, so we skipped over 13.4, that's scientific notation. If you're bored during your long weekend, read up. All right. In 13.5, we're going to talk about polynomials, and we'll start with addition and subtraction, because why not? It's the easiest place to start. So first, what do I mean by a polynomial? A polynomial is just a series of terms. All right? Terms will consist of coefficients and variables. Right? So 3x is a term. Right? 5 is a term. 2y is a term. Is that okay? So any series of terms, we have a polynomial. So, is negative 12z to the 7th a term? I mean, it's written right below the word term, so that's a big red flag.
Yes, it is.
So the coefficient there is the negative 12, and the variable is z, right? Now, we define the degree of a term based on whatever power is on the variable. So in this case, the degree is 7. Is that okay? X cubed, that's a term. What's the coefficient? 1. What's the variable on the power? Or sorry, the power on the variable? Put that backwards. So 3, right? So that's its degree. 10W, that's a term. So its coefficient is 10, its degree is 1. And finally 7. The coefficient there is 7. What's the power on the variable? There isn't one, right? So it's 0. So we say that is degree 0. Does that make sense? All right. So if I were to write negative 12z to the 7th plus x cubed plus 10w plus 7, what is that?
A polynomial.
Polynomial. All right. Good job. That's a polynomial. We do have some special names. If our polynomial only has one term, we call it a monomial. Right? It's still a polynomial, it's just more specifically we can call it a monomial. If your polynomial has two terms, we can call it a binomial. Again, it's still a polynomial, but we more specifically can call it a binomial because it has two terms. And nobody's surprised that 3 terms we call trinomial. You kind of see how those Greek prefixes are working there? Right. So if we have 3 terms in our polynomial, we call it a trinomial. And what about after that? We just give up, call it a polynomial. Right. It's just a polynomial. All right. Now, usually, we'll be dealing with polynomials of a single variable. So I might give you, for example, negative x to the 4th plus 7x cubed minus 8x squared plus x minus 3. That's a polynomial. And it's not a special one because it's got how many terms? 5 terms. So no special name, right? It's not like we call it a quintinomial or something. Right. So let's break this polynomial down into its terms, its coefficients, and their degrees. So give me a term from this polynomial. Negative x to the 4th. What's the coefficient there? Negative 1. What's the degree? 4. Give me another term. Okay, you guys want to go out of order? No worries. What's the coefficient? 1. The degree? 1. What is the degree? It's the power on the variable, right? So what's the power on x there? It's a 1. Give me another term. Grab bag. You can go in any order you want. All right. So we actually have 7x to the 3rd as a term. All right. It's important not to split it up. It is a whole term. Now, what is the coefficient part? 7. And the degree part? 3. Another one. Negative 3. What's the coefficient? Negative 3. What's the degree? That's the degree 0. There's no power on x because there's no x there. Is that okay? So there's one left. Were you trying to avoid the negative? Negative 8x squared. What's the coefficient? Negative 8. What is the degree? 2. Do you guys see how we broke that polynomial down? It's a series of terms. Terms are just coefficients and variables. And those variables have powers. Those powers are degrees. Now, in this particular case, I had this written in descending order. What do you suppose I mean by descending order? From highest degree to lowest degree. 4, 3, 2, 1, 0. Does that make sense? That's going to be an important concept. The leading term would be negative x to the fourth. What did I mean by leading term? The first one when it's in descending order, the one with the highest degree. Does that make sense? As a subset of that, the leading coefficient is negative 1. So do you see how I pluck that information out? In a polynomial, if it's written in descending order, your leading term is that one with the highest degree, and the leading coefficient is its coefficient. Make sense? Last piece. The degree of the polynomial. Now each term has its own degree, but we can say that the polynomial has a degree as well. And what do you think that's going to be? The highest one. Whatever the highest degree is for any term, call that the degree of the polynomial. Is that okay? So here's our leading term. So what's the part that's not the variable? A negative, right? But it's not making sense to just say a number is negative. Negative what? Negative 1. If it were negative 4, you'd write the 4. It's the same thing as if I just write x. What's its coefficient? 1. The 1 is understood to be there. If there's no number written there, it's understood to be a 1. Same thing with negative. If there's no number written there, it's understood to be negative 1. It's a good question. All right. What if I give you 8x to the fourth, y to the fifth, minus 7x cubed y squared, minus x squared y plus 5x plus 11. So this is a polynomial, and we would even call this a multivariable polynomial. Ooh, fancy. Right. How many terms? 5 terms, right? Terms are just coefficients along with variables, and this is a series of terms. So we'll break it down. Give me a term. 8x to the fourth, y to the fifth. That's a term. You guys agree? What's the coefficient? 8. Here's the tricky part. What's the degree? It wasn't tricky at all. You guys are smart. It is 9. Right? 4 from the x, 5 from the y. That makes 9. Give me another term. Now you're going to go in order. All right. Negative 7x cubed y squared. What's the coefficient? Negative 7. What's the degree? 5. 3 from the x, 2 from the y. That makes 5. Make sense? Another term. Negative x squared y, also 11. Fine. Let's look at the negative x squared y. What's the coefficient? Negative 1. That's the one that made your brain itch. What is the degree? Ah, very good. Is everybody okay with the degree being 3? I wrote it down, so that means it's right. We got 2 from the x, and how much from the y? 1. If we don't write a power, it's understood to be a power of 1. What about 11? That's a term. The coefficient is 11. The degree is 0. And you guys missed one. 5x. The coefficient is 5. The degree is 1. Is that okay? Is this written in descending order? Right, not the way you broke the table down, but the actual way that I wrote the polynomial. Is this written in descending order?
No.
9, 5, 3, 1, 0. Yes.
Oh, the way. Oh, I was looking at the table.
Yeah, no, not the table.
Okay, the way you wrote it up there. It
Yep. So this is descending order. You're right. If I wrote it in the order of the table, that is not descending order. Right? I've never had a class that just took random stuff there. That's fun. So, do we have a leading coefficient? I'm sorry, do we have a leading term, first of all? Eight x to the fourth, y to the fifth. The leading coefficient then would be 8. The degree of the polynomial? It's 9. Right? Go ahead, toss it out there. You're not losing points now. There's plenty of time for you to lose points later. All right, so that's what a polynomial is and what it's made up of. So how do we add polynomials? Well, that's actually easy. To add polynomials, all you have to do is combine like terms. You guys know how to combine like terms? Oh, hopeful for you guys. Okay. So, for example, if I take these two binomials, 5x to the fourth plus y cubed and 3x to the fourth minus 2y cubed, and I add these two binomials together, what do I do? Hint, it's written on the board.
Combine like.
Very good. Combine like terms. What do I get when I combine like terms?
I got 8x to the
8x to the fourth. If I have 5 bananas plus 3 more bananas, that makes 8 bananas. I'm hoping you guys can count bananas. If I have y cubed minus 2y cubed, what's that going to leave me?
negative 1 cubed.
In debt, a banana. Or in this case, I guess an orange. Is that okay? Did you guys combine like terms okay? You told me you knew what it was. Did you really? Yeah?
Yeah.
So that's it. So what about subtracting then? Can I take those two polynomials and subtract them? Why, yes. Yes, I can. What do you think this looks like? How about we distribute that negative through the second set of parentheses. If I distribute what amounts to negative 1 through that second set of parentheses, I wind up with 5x to the fourth plus y cubed, then minus 3x to the fourth plus 2y cubed. Are you guys on board with that? Is that okay? And now what? Combine like terms. So how many x to the fourth do we have? 2x to the fourth. How many y cubes do we have? 3y cubes. Right? You guys are really scaring me. Combine like terms. Is this okay?
Why isn't the exponent changing? Does it just stay like that? We don't do anything to it?
Ah, okay. Because we're not multiplying them now, we're adding them. Right? So if I have 5 apples minus 3 apples, that's going to leave me with 2 apples. But apples didn't change. Does that make sense? Right. Now it's all like fruit salad. Go for it.
The last thing was given wrote AX, before, what would it be? The last thing we just did.
This one here?
Yeah.
Oh, that's it. That's our answer. Sometimes the hardest thing to do is walk away. That's it. That's our answer. And this is our answer here. Right? And this is our answer here. So what if I draw a beautiful triangle and I tell you the 3 sides are y squared plus 3, 3y cubed minus y squared minus 1, and y cubed plus 2y squared. Why not? How do I get the perimeter? Add them up. So I'm asking you to add 3 polynomials. How do we add them up? Combine like terms. So what terms do we have out there? Okay. So how many, I've got a y to the third here, and I've got another y to the third term here. So how many do I have of y to the third? I have 4y to the third. Is everybody okay with that? What's another term I have? All right. So I've got y squareds here, here, and here. So how many y squareds do I have? Yeah, 1 plus 2 plus a negative 1. So that's just going to be 2y squared. Do I have a y running around anywhere? Nope. And then the last thing I have, the constants. Right? We call those constants. And 3 and negative 1 gives us 2. Is that okay? You guys on board? Now let's start the fun part. In 13.6, we're going to talk about multiplication of polynomials and special products. All right. So we talked about adding and subtracting. How do you add? Combine like terms. How do you subtract? Distribute the negative and then combine like terms, right? Multiplying is going to be its own beast. Right? What if I have monomials? 5x squared times 2x cubed. Now, there's no plus or minus here, right? We catch a break there because that always gums up the works. Right? So how do I multiply this? I get x to the 6th. That's part of it. You actually get x to the 5th. You lied. If you multiply like bases, you add the exponents, and you get 10. All right? So 10x to the 5th. Is that okay? What if we have a monomial and a trinomial? So let's say that I give you 1/6 x to the 4th y to the 5th. That's a monomial, just one term, right? Times 12x minus 3y plus 4. What does this look like? Yeah, distribution. Can I distribute that monomial to each term in the trinomial? I drew arrows, so that's a hint. Yes. So each one of these is like the monomial times monomial. So basically, multiply the coefficients together, and then when you multiply the bases together, you add the exponents. So this means for my first term, I'm going to get 2 x to the 5th y to the 5th. Because what is 1/6 times 12? Just 2. And when I multiply the x's together, I add those exponents. So the 4 plus 1 gives me 5. And y just came along for the ride this time.
Shouldn't like, okay, no, never mind. That's its own term, 1/6 x to the 4th.
Yes, that is one monomial right up front. Now let's look at the second one. What's that going to give me? Well, it's a positive times a negative, so negative, right? 1/6 times 3. What's that going to be? Close. 1/2. You guys agree? 3/6. What is that going to give you? 1/2. X to the 4th, y to the 6th. One more term. Positive times positive is positive. So now we're multiplying times that last term. 4/6 reduces to 2/3, and x to the 4th, y to the 5th. Neg action. Do you guys see how we distributed? Is distributing okay? All right. Yes, distributing okay? Right. You can lie to me, but I do have to grade your test, so I'll know eventually. Right. It all comes out. How did I get the 2? So when we multiplied for that first term, we're doing these two monomials, right? So you multiply the coefficients together. So that means 1/6 of 12. Wouldn't that be 12/6? That's all right. It's a good question. 12/6 is where we get 2. If, you guys don't have to impress me, if you just have no faith in yourselves, I'll never know. All right, that wasn't so bad. Level up again.
So that was it? That was it?
That's it. That's it. That's the answer. All right, we're just multiplying.
Not combining, right?
Let's see what happens here. Well, did we have any like terms back here? That's a good question. None of them are the same. They're all different, right? X to the 5th, y to the 5th. Well, we don't see any of those. X to the 4th, y to the 6th. There's nothing else like that. And x to the 4th, y to the 5th. Nothing else like that. That's it. I know, sometimes the hardest thing to do is walk away. If we do two binomials, let's say 3x plus 2 times 2x minus 1. So what is this? I meant the process, not the actual number, but that's great. Yeah, we could interpret this as distribution, but the thing is, I'd have to take the entire first binomial and distribute it to each term of the second one, right? But then I would have each of those in front of a parenthesis, so I would have to distribute again, right? So we could distribute, distribute, distribute. That's brute force. But in this case, we have foiling. All right, you guys remember FOIL? All right, again, it's something we introduced in the class before, but if you're very rusty, let's talk about it again.
Yeah, I just did that.
Which class before?
Beginning algebra. So what we mean by FOIL is we know that we basically have to distribute everything in here to everything in here. So we basically have to make sure that we multiply every possible combination. And it's not too hard to keep track of it when it's just 2 and 2. F stands for the firsts. We have to multiply the firsts together. O stands for the outsides. We have to multiply those two together. I stands for the insides. We have to multiply those together. And L stands for the last. So that way we make sure that we've gotten every possible combination. All right? So, multiply the firsts. What is 3x times 2x? 6x squared. Is everybody on board with that? Outside, what is 3x times negative 1? Negative 3x. Inside, what is 2 times 2x? Plus 4x. Last, what is 2 times negative 1? All right, you guys started dying out there.
Is that not the same thing as distributing?
It is. You're distributing, though, multiple times. And that's fine. FOIL is just a mnemonic.
If we show like a different way on the test, is this like this?
I'm going to show you another way.
Oh,
Right? FOIL is probably the way most people will like to do this, but no, that's not the only way to do it. We do have a pair of like terms on the board. Notice that negative 3x and 4x are like terms, so they combine. We have 6x squared, because there was no other term like that one, and then we have plus x, and then we have minus 2. Is that okay? All right. So when you have two binomials, FOIL is a mnemonic for a quick way to distribute them out. If you brute forced it, it would be like taking 2x times 3x plus 2 and then minus 1 times 3x plus 2. Then what would you have to do? Still distribute.
Really?
You'd have 6x squared plus 4x minus 3x minus 2, and then you would combine like terms. So if you just distribute, it does work. All right? FOIL is just kind of a quick way to make sure you get all of those distributions in one go. All right? There's another way we could think about it. And that is geometrically. What's the area of a rectangle? Okay. Length times width. Am I not multiplying two things here? So maybe I interpret this. Oh, that's bad even for me. As multiplying a length times a width. if this is a 3x and a positive 2, and this is a 2x and a negative 1, right? Length times width would give me area, right? So for each box, what is 3x times 2x? 6x squared. For the next box, what is 2x times 2? 4x. For the third box, what is negative 1 times 3x? Negative 3x. And for the last box, what is 2 times negative 1? So those are the areas of each of those little boxes. How do we get the total area? Add them up. Add up all 4 boxes, and that's the total area, right? But isn't that the same thing as combining like terms? This is just a visualization of what you're doing. It's all the same thing. You have a 6x squared. There was no other x squared. You have combined a plus x and a minus 2. So there's lots of ways of approaching it. It's all coming down to distribution. Brute force distribution. Fancy mnemonic, because binomials are always going to work the same way. Foiling will make sure you get all of those. Or a geometric interpretation. Right? I'm never going to force you to use one or the other, but they all have their place. So what if I wanted to do x plus 5 times 3x minus 2? What method do you guys want to use? Let's FOIL it out. Yeah, I mean, that's not unusual. Foiling is usually what people glomp onto. What's your first? 3x squared. What's your outside? Negative 2x. What's your inside? 15x. And what's your last? Negative 10. Combine your like terms. You just have the 3x squared. There was no other square term. But then you have 13x and minus 10. Is everybody on board with that? Was that okay? Well, let's level up. What if I want to multiply a binomial with a trinomial? So we have, for example, 2x minus 1 times 5x squared minus x minus 2.
Same process.
Not quite. You could brute force it, but there's going to be more because it's not just 2 terms times 2 terms. So how many different multiplications are going on here? A few more. There's going to be a few more. So there's no catchy mnemonic. You can't FOIL it because it's not just first, outer, inner, last. You've got that middle term there, right? So if you were creative, you might develop some kind of like phemoimal to deal with that middle term in there. But this is just starting to get too much, right? So 2 ways. Brute force, 5x squared, 2x minus 1. Minus x, 2x minus 1, minus 2, 2x minus 1. Do you guys see that? Right? Each term. And then what do you have to do? Distribute some more. All right. So that's going to give you 10x cubed minus 5x squared. You guys on board? Minus 2x squared plus x minus 4x plus 2. Did we distribute them all? And then what? Combine like terms. What are all my cubes? Where are my cubes at? 10x cubed. What about my squares? Yep. Minus 7x squared. What about my x's? Y'all need to know about my x's. Minus 3x, positive 1 minus 4. You guys agree? And finally, the constant plus 2. Brute force, it works.
Can you just do the draw one?
Let's do it. I was going to do it anyway, but now I can blame it on you.
Because the first one was too long, I was just.
Yeah. So this time, if I interpret this geometrically, I'm going to have a length and a width. I just have 2x and minus 1, so I'll just do 2 rows. But I have 5x squared and minus x and minus 2, so I have 3 columns. Does that make sense? So this is what I'm a visual person, as completely blind as I am. I'm a visual learner. So all this is doing is giving us a visual to make sure that we don't miss any of the multiplications that we're supposed to do. Starting off with 5x squared and 2x, which is 10x cubed. For the next box, length times width, 2x times negative x, negative 2x squared. The last box in that row, length times width, 2x times negative 2, negative 4x. Next, negative 5x squared. Next, positive x, very good. Negative times negative is positive. And finally, positive 2. So when we add them up, because the total area is going to be the sum of all these little areas, we just have the 10x cubed. Got it. We've got minus 7x squared. We've got minus 3x and 2. You guys like the box? I think it's a good visual aid. You don't have to use it. If you are anti-box, then go forth with your brute force. All right? All right, so that's how multiplication works out. But we also said in here that we are going to talk about special products. All right, and there are 3 of them. So what happens if I take a plus b times a minus b? All right. Well, this is binomial times binomial, so we could FOIL, right? Sure. If I FOILed it, your first would be a squared, your outer would be, but it would be negative, right? Whereas your inner would be positive ab, and your last would be negative b squared. Is that so? And what's going to happen? Yeah, negative ab plus ab will cancel out, right? And so we get a squared minus b squared. All right. What if I wanted a plus b all squared? Now we remember that we can't distribute powers. What does a square mean? The same thing twice, right? So a plus b squared means a plus b, a plus b. You guys agree? Well, that's binomial times binomial, so I could FOIL. Your first, a squared. Your outside, a positive ab. Your inside, a positive ab. And your last, a b squared. And it's all positive, isn't it? So this time, instead of canceling out, we get a squared, and then we get plus 2ab plus b squared. Is that okay? One more special product, a minus b, the whole thing squared. Well, again, what does a square mean? Same thing twice. Now that sort of balls people up. You guys glomp onto that first formula, and then you love it so much that when you see a square, you tell me that one is plus and one is minus. No, if it's a square, what does that mean? The exact same thing twice, right? No changes. So this would be a minus b, a minus b. If we FOIL it, your first would be a squared. Your outside, a minus ab. Your inside, also a minus ab, right? And then your last would be Yeah, because negative b and negative b would make a positive b squared. You guys agree? So you get a squared minus 2ab plus b squared. And they have names. A plus b times a minus b is always a squared minus b squared, and we call that a difference of squares. It's all what it says on the box. Difference squares. See what they did there? For a plus b squared, we get a squared plus 2ab plus b squared. For a minus b squared, we get a squared minus 2ab plus b squared, and we call those perfect square trinomials. All right? So the thing with these special forms, you don't have to use special forms here. You could just brute force it, FOIL it out, or whatever. The thing is, eventually, everything in math is a two-way street. So once we learn how to walk forward, then we have to learn how to walk backward. If you didn't bother to learn how to walk forward the right way, walking backward is going to mean you're falling on your butt a lot. All right? So for these special forms, let's try practicing these special forms. All right? Not resort back to just brute force. So let's say I wanted to, for example, multiply 3x plus 2 times 3x minus 2. First, is this a special form? Wink, wink, nudge, nudge.
Yes.
Yes. Which one is it? It's a difference of squares. Who's playing the role of A? 3x. Who's playing the role of B? 2. So it's a squared minus b squared. So what is a squared going to be? You're allergic to this math. A squared is going to be 9x squared. What is b squared going to be? 4. So it's 9x squared minus 4. And that's it. Like magic. I see the doubt on your face.
Yeah.
Right? FOIL it out. It'll work. But I want you to get used to trusting in this special form. When you have this a plus b, a minus b, how does it always multiply out? A squared minus b squared. So that means 3x plus 2, 3x minus 2 is going to be 9x squared minus 4, and you can walk away. What if we had 4 minus y to the 5th, 4 plus y to the 5th? Is this a special form? Yes, right? Since we're in that section. A minus b, a plus b. So that's that difference of squares. You guys agree? Who's playing the role of A? 4. Who's playing the role of B? Y to the 5th. So a squared minus b squared. What is 4 squared? 16. Minus. What is y to the 5th squared? Y to the 10th. That's it. That's all there is to it.
So if we FOIL it, we get that result.
You will. But I want you to get confident doing this because eventually we're going to go backwards. So get confident. If you want to, try the formula, then FOIL, and you can see if you fouled it up.
Wait, so that's like factoring, right?
Well, that's what we're going to do when we turn it around. Yep. The big bad. What if I even bring out your arch nemesis? Two x squared minus a third. 2x squared plus a third. Is this a special form? Yes. Which one is it? It's a difference of squares. A plus b, a minus b, right? Who's playing the role of a? 2x squared. Who's playing the role of b? 1/3. It always multiplies the same way. A squared minus b squared. So what's a squared going to be? 4x to the 4th. You guys agree? Minus 1/9. And you're done. Walk away. Really not bad, right? If you brute force it, you'll get there, but it's going to be a little bit messier. But it works. All right? All right. That was all the difference of squares. What about those perfect square trinomials? So here we have x plus 4 squared. Right? Now, this is not x plus 4x minus 4, right? Because what does a square mean? It'd be the same. So it's x plus 4, x plus 4. So this is not a difference of squares. This is a perfect square trinomial. And that worked, a squared plus 2ab plus b squared. So basically, we have a squared and b squared, and then what we have to do is multiply these together and double it. That's the 2ab. All right? So who's playing the role of a? X. Who's playing the role of b? So, a squared, x squared. All right? What is 2ab? Well, a times b would be 4x. Double it is 8x. And then b squared, 16. Ye of little faith, foil and ye shall see. All right? But I want you used to this form. All right? I'm going to beat you over the head with it because it's not going away. What if I had y minus 6, quantity squared? This is a perfect square trinomial. It's y minus 6, y minus 6. The same, right? So it's a perfect square trinomial. A squared minus 2ab plus b squared. Who's playing the role of a? Y. Who's playing the role of b? 6. So what is a squared? Y squared. What is a times b? Negative 6y. Doubled is negative 12y. And then b squared is 36. All right. Again, try the formula. If you're in doubt, go back and brute force it. Verify that you do get to the same answer every time, as long as you're doing it right. You know, that is a caveat. Do not distribute the exponent. That's an angry red X on your page just waiting to happen. All right? Let's try some more of these. What if we wanted to do this is a test. It's only a test. What if we have 2x plus 3 all squared? That's a perfect square trinomial because it's not different, it's the same, right? That's what a square means. 2x plus 3, 2x plus 3. So this time, who's playing the role of a? 2x. Who's playing the role of b? So a squared is going to be 4x squared. A times b would be 6x. Doubled is 12x. And then b squared is, what's 3 squared? 9. Is that okay? Then what if I wanted 5xy squared plus xy all squared? Yep. So this is a perfect square trinomial because it's the same thing twice. It's not the plus and the minus. It would be plus and plus, right? So this is the perfect square trinomial. Who's playing the role of a? 5xy squared. Who's playing the role of b? xy. So what is a squared? 25. You got it. X squared y to the 4th. Pat on the back. That's your a squared, right? What is a times b?
5 x to the second, y to the third.
Yeah, 5x squared y cubed. Doubled? 10. X squared y cubed. That's your 2ab. Multiply them together and then double that coefficient. And finally, what is b squared? X squared y squared. It's not hard, but you have to practice it. And not just practice it like by saying, I'm just going to do a brute force and forget about it. That's not practicing it. All right? Try using those special forms, using those perfect square trinomials and those differences of squares. What if we wanted to do 7x minus 5y minus 2 times 7x minus 5y plus 2. So this is a bit of a boss fight. It's a mini boss fight. Okay? You could brute force it, but maybe we notice something. And by maybe, I cross my fingers and hope.
There's like terms. Always.
Well, let me write it separately. If I grouped the 7x minus 5y together, since it's the same, right? Do you see that I have a minus b, a plus b? Do you see that I have a minus b, a plus b? Who's playing the role of a? 7x minus 5y. And who's playing the role of b? 2. So that's a difference of squares. How does a minus b, a plus b work? What's the rule? For the difference of squares, hint the name. A squared minus b squared. When they're different, when it's the difference of squares, it's just a squared minus b squared. All right? So that means we have 7x minus 5y squared minus 2 squared, which is 4. A squared minus b squared. Is that part okay?
Are you going backwards?
Ah, no, but we have another step. Do you guys see how I got a squared minus b squared? A minus b, a plus b, a squared minus b squared. That's the difference of squares. But we're not done. Because what do you notice for this first term? That is, that's the perfect square trinomial. Because it's squared. And what does a square mean? The same thing twice, right? So minus, minus. So this one is going to be with the double in the middle. All right? When they're the same, it doubles up. When they're opposite, it cancels out. Right? So, multiplying out just this parentheses squared, a minus b, the whole thing squared, who's playing the role of a? 7x. Who's playing the role of b? 5y. So what is a squared? 49x squared. It's okay. What is a times b? Negative 35xy. Doubled would be negative 70xy. B squared would be 25y squared. And negative 4 just comes along for the ride. And now we're done. Look at what we did. Up at the top, what's the main operation? It's two things being multiplied, right? And at the bottom, I've done away with all that. It's all addition and subtraction. That's what multiplying out does. You take it multiplication, and you rewrite it as just addition and subtraction. No more multiplication left. One last piece. What if I told you f of x was x plus 3, and g of x was x squared minus 3x plus 9. So I give you these. And I asked you to find the product function. How did the product function work? We multiply them together. So this means I would have x plus 3 times x squared minus 3x plus 9. You guys agree? And now we know how to do that. Probably draw the box. You could brute force it, but I think the box works here. So I can make 2 rows and 3 columns here because it's a binomial and a trinomial. Right? What happens if they're both trinomials? Yeah, 3 columns, 3 rows, right? So this is x and 3. This is x squared, negative 3x, and 9. Let's start at the top left, and you guys tell me how to fill in the boxes. That top left box, x cubed. That top middle box, negative 3x squared. The top right box, 9x. Is everybody okay with that? The bottom left, 3x squared. The bottom middle, negative 9x. The bottom right, 27. So what do we get? We do have an x cubed. That's going to hang around. 3x squared minus 3x squared, that cancels, right? Negative 9x plus 9x, that cancels, but then we're left with plus 27. So that is our product function. Is that okay?